Anyone with any questions regarding what we were doing the last day? Okay, so I believe the answer is a no. So let us proceed with this. So a brief recap to what we were actually referring to, and at least for the new people. So we were basically dealing with the methods of solving equations, and particularly through the matrix method and the determinant method. So the people who have joined new, just wanted to confirm, you all are familiar with the matrix method of solving a system of equation, right? The Martin's rule that you had read in your maths in 11 and 12. Are all of you familiar with that? The new people who are joining for the first time? Do you all recollect that we had something
Sir,
like that?
sir, can you give us a short recap of that rule once?
Um, sure, Arnab. Let me just scroll back up. In that case, um, we have already discussed that over here. Maybe we can go through that once more. So, can you see the screen, Arnab?
Yes, sir. Yes, sir.
This one. So, since we are mostly interested in application of some mathematical methods to economics, we started off with some economic, you can say, equations itself. So let us say that the demand function is Q equals to alpha minus beta P. Why is it taken in this way? Because demand is inversely related to price. And the supply function is Q equals to minus gamma plus delta P. And since supply is positive, we have a plus, where alpha and beta, gamma, delta, all of them are positive. So if we are trying to find out the equilibrium price and quantity, so what we can do, we will basically try to solve these two system of equations, right? People who have joined new, if all of you can respond, if you are understanding this part. The moment when we are trying to solve for an equilibrium in economics, it's nothing but finding the solution to this system of equations, right? Because what is the equilibrium? It's the equilibrium is a point where both the curves meet. And when you're solving a system of equations, what are you finding? You are essentially finding the same point, right? So this is basically your demand and this is your supply. So this is your demand curve, this is your supply curve. This is the equilibrium that we write. And when you're solving the system of equations, this is essentially the point that we're looking at. So this is the set of equations that we are trying to solve for. What are my two unknowns? Q and P. So what we try to do is that we try to write the system of equations in matrix form. And how do we write that? The first is the coefficient matrix where you can see, so the coefficients are 1 and 1 over here. So 1, 1, column wise, beta and minus delta. My two unknowns are, the first one is Q, the second one is P. And on the right hand side, the constant vectors are alpha and minus gamma. So essentially, what are the equilibrium or solutions to this set of equations? It will be the inverse of this coefficient matrix into this alpha times minus gamma. The new people, are you aware of how we find out the inverse of a matrix? Do you all remember
Yes,
that?
sir.
Okay. So essentially, this was the Martin's rule or the matrix method of solving for a system of equations. And why do we need these methods, even though some simple methods that we have been using till date are already easy to solve or relevant? Because you can understand that it need not be only two variables. We can have even more variables that we might need to solve for. And the more you take the number of variables, the methods that we have been using till now might get a little complicated. Which equation to add with what, which to subtract with what. So it is always better to have a standard method where everything can be represented in a clean way. And the technique of solving it is essentially the same. Here in the Martin's rule, when you are taking, let's say, three equations to find three unknowns, essentially the size of the matrices will change, but the method of obtaining the values will not change. And there also you need to take the inverse of the coefficient matrix, and adjust it accordingly. So after we went through this one, we again so this was a solution. So this I think you all can understand, or I'll be sending across the PDF to you all, so you all can just have a look at the way in case you have forgotten how to find the inverse. And then there is another method that we looked at is the determinant method of solving. Okay. So what we are trying to do over here is that so these two set of equations remain the same. So this is my equation 1 and this is my equation 2 that was there. Nothing has changed over here. And then we are trying to frame two determinants that we can place in the numerator and denominator to give us the answer. So the idea, at least you all can just have a look by yourself also after this, that the determinant is basically that we are placing in the denominator of both of them is same. I think you can just see this on your left and on your right that you can see. And what is that? It's basically the determinant of the coefficient matrix. Because if you remember over here, what was the coefficient matrix that we had? It was 1, 1, beta, and minus delta. So we are basically taking the determinant of that in both cases. And accordingly, the numerator is getting adjusted. So these are the two methods that we spoke of, and then we have seen how we can actually use these methods to solve more and more system of equations and how it is helping. And then we came to the idea of consistency and inconsistency. Simply putting, consistency and inconsistency basically tells us whether the system of equations are actually solvable or not. That's the idea. When you solve the system of equations, whether you will actually end up getting a solution or not. And what we saw is we can have three types of cases. One is that you can see over here that I have drawn the graph on your right. What is basically happening? That idea is when, for example, this is a two variable equation. If you plot it on a graph, it will be a straight line. So one possibility is that both of them intersect and you have one point of intersection. So this is the case of a unique solution. Another case is that you can see over here on your right on the screen, this one, infinite solutions. The idea is that the two equations are essentially overlapping. So all the points on one line is actually a solution for the other. So there are infinitely many solutions. And the third one that you can see on the left of your screen is the case of inconsistent solutions. That means these two lines will never meet. As a result of which you will never get a solution. Okay. So these are the possible three things that can happen when you start with solving an equation. And after looking at all these things, we try to understand that what would be the conditions for consistency and inconsistency. That means if you are given this, so this is a general set of equations, right? So when you are given this general set of equations, how do you understand whether the system of equations will be consistent or not? Okay. I'll just give you some time. I'll send the PDF across. You can just have a look at this. And if you have any questions, we can get through it again the next week. Okay. The newcomers, especially I'm talking about. And others also, if you have any doubts regarding these portions, you can just raise them in the next class as well. So after this, we were now going into the idea of vectors. So these are some questions that we did, and then we went into the idea of vectors. So just so people, the new people, are you all familiar with the idea of vectors? Have you all learned it earlier? If the new people can just respond once, are you all familiar with the idea of
No,
vectors?
sir. No, sir.
No,
No,
sir.
sir.
No, sir.
Do you remember seeing some expressions like this in your math books?
Sir, not in maths book, but in class
Was it
11.
there? Like,
Sir, not sir. No, sir. Not in maths book, but in class 11 physics, I had seen all this kind of equations.
okay, so you might have used these in physics
Yes, sir.
in some chapters, I guess.
Yeah, in
So do you
ICAP and J.
recollect
Yeah.
what this is? Like, yeah, do you
I
recollect
can,
what this is?
sir, I guess ICAP is basically the X plane and JCAP is basically the Y plane. I guess it- like this only.
Uh, Not really. The people
Sir,
who
then I
were
don't know.
who are there in the okay, who are there in the earlier class, you all are clear with this idea, right? That I explained earlier. This was the probable expression that you might have seen in your math books earlier, and this notation is essentially the same. Is it clear with you all? The people who were there in the last class? I think I had explained this part. Notational wise, the notation that you might have
Yes,
seen
yes.
over here is essentially the same. Okay, Arnav, so let's do something that I'll send this PDF across. You have a look at this part, especially this vectors part, the people who are new, at least, because this is a part, this is a little different the way we are trying to analyze it and the way we are trying to portray it. So it will be, it might confuse you later on if you're not clear with this basic. Nothing too critical, but it might lead to very simple confusions here and there. So what the idea is, let me just recap this part once more. Have a look over here at this part. Can you see this 2 by 2 matrix, all of you? This 3, 0, 1, 2. This is a matrix, right? So this is the order is 2 cross 2. So this 3 comma 0 is essentially the first column of the matrix, and this 1 comma 2 is essentially the second column of the matrix, right? So these two we often used to, in earlier we used to call this as matrices only, like this is a 2 cross 1 matrix and this is a 2 cross 1 matrix. But now henceforth we will be calling these as vectors. Okay, essentially people who have read vectors earlier in your maths and anywhere in any other subject, the idea is essentially the same, but just the representation is different. Any matrix which has one row or one column is known as a vector. Like for example, if I'm writing it in this way, 1 comma 2, this is essentially a column vector. And if I write this as 1 comma 2, this is essentially my row vector. Okay, so if I denote like let's say capital A as 1 comma 2, then A transpose is nothing but 1 comma 2. Okay, the notations and everything remain the same as matrices, but we are not going to use that I cap, J cap, and other notations that you might have seen earlier, because truly speaking, in economics, those really don't make any sense for the timing. We are not really bothered too much about the direction, so to say, but it is essentially the idea that matters of why we need vectors at all in the economic analysis. So we are not going to use the I cap, J cap analysis, and vectors are essentially part of matrices itself. Okay, so that means if I'm trying to plot this graphically, what am I looking at? What is the idea of a vector or a matrix, so to say? So this is my XY plane or 2D plane, whichever way you call it as. Let's say I want to plot this vector A. What we are doing, it's basically the first component is the x-axis component, and the second component is the y-axis component. That means if you have to reach the tip of this vector, what you will do, from the origin, you will move 1 unit to your right and 2 units above. So this is the vector
Sir,
that we are looking at. Okay, this is your vector A,
sir,
which is 1, comma 2.
Sir,
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 So your screen.
your screen paused.
New
Sir,
joiners,
your
is
screen
it fine?
paused.
sir, we are unable to see anything. The your screen share is not visible to us.
Yes, Anna? Yes, hello?
Hello, we are unable to see anything. Your screen is not visible to us.
Oh, you can't see the screen.
No, nobody
Oh,
can see the screen. That is why everyone is messaging you.
okay, okay. Okay. Okay, let me reshare, Ina. Let me reshare. One moment. Yes, Ina, I heard. I heard it. Okay. Shit. Hello, everyone. Can you hear me now? I'll just reshare. I think there was some network.
Yes, sir.
Yeah, very sorry. Thank you for letting me know. Can you see this now?
No, sir.
Yes, sir, we
No,
can.
sir. Yes, sir. Sir, now we can see.
Not. Yeah, just all of you, if you could confirm that. Yeah, is this fine now? Can you see a vector drawn? And
Yes, sir.
oh, thank you, everyone.
Yes, sir.
So coming back, I'm so sorry. I got disconnected. Till what did you all hear? I don't remember. Should we go through this vector expression once more? Okay. Okay. So
Yes, sir.
coming back to this. So if I am calling this as my vector, capital A equals to 1 comma 2, what does this mean graphically? Let us understand that. So what we basically are talking about is the first component basically represents the units on the x-axis, and the second component represents the units on the y-axis. So if you want to plot this vector, what we will do, we are basically saying that this vector basically tells us you go one unit along the x-axis, and after that you go 2 units along the y-axis. So this is your vector that we are talking about. Okay. So this is essentially the idea of vectors, how much you need to travel along the axis. Okay. In case any of you will be wondering that what is the difference between writing it in this way and writing it in this way. That means simply speaking, this is the way we represent the coordinates of a point, and this is the way I'm telling to you to represent a vector. So the difference is a point is basically only this one. Right? Can you all see this black dot that I'm drawing over here? Can you all see that on the graph that I've drawn on the tip of the red arrow? Can you see this?
Yes, sir.
Yes, sir. Yes.
All of you?
Yes,
Can
sir.
anyone of you confirm? Can you see that? I've drawn a black dot on the top of this red arrow. Is it visible at all? This location. You're basically telling the location, but when you're denoting a vector, you are essentially telling the path how to reach there. That is the difference, I can say. Okay. So this is a measure of the vector. Okay. This is how we represent a Cartesian point, and this is how we are going to represent a vector. A point is basically a location, and when you are trying to say the vector, it is basically telling you the shortest distance, you can say, that if you are trying to reach from the point of origin to this tip, how you are going to reach it in the shortest way. Okay, that's the idea essentially, graphically. So
Sir,
this is the Cartesian point, and this is my vector. Okay, and just to have another thing added on over here,
है ना, आई गेस सर का वॉइस बीच में रुक जा रहा था ना सबके लिए।
हाँ वो डिस्कनेक्ट हो गया लगता
हाँ
है।
हाँ मेरा भी अटक रहा था।
कनेक्टिविटी इशू है शायद।
नैन
हाँ
कल रैकेट लेके आएगा भाई।
am I audible to you all now?
यस सर। यस सर।
Yes, sir.
Okay. So I think I'm facing some internet issues today. That's why there is this problem. Should we continue the next day, or you all can just continue right now?
Okay, sir.
Because I'm not sure if the connection will not cause any problem later. What do you all suggest? Others? Should this be fine? I'm not sure.
Sir, sir, if we are facing the same problem again and again, so we can continue on next day.
Yes, Hina, I think that would be better because I think there is
Yeah,
some
because
issue
back
today.
to back
That's why.
continuously the problem is there, then what's the use? Or it's a waste of time.
Yeah, exactly. So I'll cover it up definitely, not to worry. I'll just cover today's content as well. So we'll continue the next day and we'll try to fix another class. Okay. Really sorry, everyone. I'm not sure
Sir,
why
sir,
this
sir,
internet issue is
No,
today.
sir, no issue, sir. Sir, I ask you
no
something.
problem, sir.
Yes, Arnab?
Sir, yesterday, did you send the email of the PDF?
No, Arnab. No, I haven't sent. I'll be sending all of
Okay,
them together.
okay, together. So,
All
sir, by today or day after tomorrow, anything?
by tomorrow. If
Okay,
not
sure,
today,
sure,
then by tomorrow, surely. Okay, so
sure.
really sorry everyone. I think if the internet problem persists, then it will be pointless. We'll continue the next day, the next weekend, I mean, and any other changes I'll notify. Okay. Thank you so much and really sorry.
Okay, sir.
This way it might be
Problem, sir.
difficult for you all to understand. Yeah. Okay, so we are ending the call today and we'll continue the next week.
Thank you, sir.
Thank you, sir.
Thank you, sir.